Okay, let's have a look at the solutions to this test. Question number 1, I've already put the table on the board. It says the heights of 120 plants were measured in centimetres. The table below shows a grouped frequency distribution of the heights. Do not be put off by that phrase, grouped frequency distribution. It just means a group data table. Okay, so here is the grouped frequency distribution, or the group data table, and it says underneath the table, calculate an estimate for the mean height of a tree, 4%. Okay, estimated mean height. Well, if you're going to work out a mean of something, what you need to do is add up all the bits of data and divide by however many bits of data you've added together. So if I had 7 numbers, for example, 7 heights, I would add up the 7 heights to get a total and divide by 7. So in this particular example, what I've got to do is add up all the heights and divide by however many heights that I need to add up. Well, the biggest mistake that people make when they've got a question like this is the fact that you have got here 1, 2, 3, 4 group intervals. So the temptation is for most people to add some numbers up and share by 4 because you've got 4 group intervals. That is exactly what you should not be doing. If you read the question carefully, it says the heights of 120 plants were measured in centimetres. So that means you've got 120 heights to consider. 120 heights means you will have 120 heights added together and you need to share by 120. So my first line of calculation would be to say that the estimated mean, and I'll explain why it's estimated and not exact in a minute. The estimated mean height is going to be equal to, I'm going to add up some numbers and then afterwards I'm going to divide by 120 because there's 120 plants in the question. Now unfortunately, or fortunately as the case may be, but unfortunately I would say for most people, you do not have the individual heights of all 120 plants. If you did, you'd be able to just simply add them all up. It might take a while, but you'd get there on a calculator, get the total and divide by 120. We do not have the information in that format. What we have given is that 32 plants lie between 32 and 40 centimetres, but you have no idea what their individual heights are. They could be something like 33 centimetres, 34.8 centimetres, 37.2 centimetres. I have no idea. So you can't add up the individual heights and get a grand total of 120 results and thereby divide by 120 to get the answer. So what do? Well, what we do is we make an approximation to this calculation, hence estimated mean value. We introduce a third column. Now this third column I suggest you do in a colour. Sometimes in the exam they will actually give you this column ready built into the table and say to you complete the table first. But if they don't, you need to do it yourself. And this third column is known as the midpoint column for the data that you're dealing with. And what I'm going to say is that the midpoint from 32 to 40 is the halfway point from 32 to 40. Well, if you think about it, the halfway from 32 to 40 is 36. Now, if you're not sure, because the numbers in the table that you've got in the exam, for example, are really awkward numbers, and you don't know what the halfway point is, a little rule that you can do to get the answer is add the two numbers together, 32 plus 40, 32 plus 40, and that would give you 72, and then find the halfway point by sharing it by 2. And if you did that with the calculator, you'd get the answer 36. If you can see what the answer is straight away in your head, you can just put it straight down. Okay, the next one, 40 to 48. I need to know what the midpoint is. Well, I think it's fairly straightforward to see that the midpoint is 44. The third one, 48 to 56, is a bit harder. You can either say 48 add 56 on the calculator and then divide the answer by 2. Or if you can see straight away, you can put the answer down straight away. The answer is 52. And then the midpoint, 56 to 64, halfway between 56 and 64 is the number 60. So that's the first step, to work out the midpoint values. And what we're going to say now is that we have basically got 32 plants. They lie in the first interval. I don't know what their individual heights are, but I am going to say let them approximately be 36 centimetres high each. Now that means I could write, okay, the first plant is 36 centimetres high, plus the second plant is 36 centimetres high, plus 36 and there's 32 of them. So I could write out all 32 of those being added together, each one being 36 centimetres high, approximately, because it's an approximation. But of course that is ridiculous, that takes too long. Much more efficient would be to say I have got 32 plants, 32, I'll go back to blue for this, 32 plants, and each of them is 36 centimetres high, approximately. So if I wanted to add them all together, I just have 32 lots of 36 to work out. Then I've got 43 other plants, and they are approximately 44 centimetres high each. They're not exact, approximately 44, the midpoint high. So instead of doing an add up sum, what I'm going to say is we've got 43 plants, each of them is 44 centimetres high. So I say 43 times 44. I've also got 21 plants, and they're approximately 52 high. I've also got, let me extend that on a bit, I've also got 24 plants, and they are 60 high. So 24 lots of 60. So if I want to find a grand total of all the heights of all 120 plants added together, I need to take that total, which is for the first set of results, and add it to the total for the next bunch of plants, and add it to the total for the next bunch of plants, and then for the last bunch of plants I need to add them as well. And that is how you get the grand total as an estimated answer for the total height of all the plants. Fine. Now we work out from a calculator what each one of these on the top line is going to be. So if I get a calculator, very quickly, 32 times 36 is equal to 1,152 for that, plus for the next batch of 43 plants, 43 plants times 44, 1,892 is the total height of all those plants, plus I've got 21 lots of 52, that's 1,092 is the total height for that particular group of plants, and then I've got 24 plants times 60, 1,440 is the total height of that last group, and I now need to share by 120. Now a little hint, mistakes often occur at this point in the calculation. If you were to just type in, as I'm going to do now, 1152 plus 1892 plus 1092 plus 1440, and then simply press straight away divide by 120, you're going to get the wrong answer. And you're going to get the wrong answer because when you do that on a calculator, what the calculator does is you have that plus that plus that, and then when you say plus 1440 divided by 120, all the calculator would do is actually just divide the 1440 by 120, get the answer to that, and then add it on to the others at the end. Now that is not the sum I want to do. I want to add all the top line numbers together first, all of them first, and then divide the final answer by 120. So after I put these numbers in, I'm going to press equals and get the answer 5576 on the calculator for the top line. Then we say divide by 120 afterwards. So you get 5576 divided by 120, and you get an answer of 46.5, we'll do it to one decimal place, centimetres, and that is the estimated height of one of these plants from that group frequency distribution. Okay, it's quite a long question, so I'm going to stop the video at this point and continue on with the solutions in the next video.